So we are today going to start a new chapter, and the chapter is about integration. Others can call it integration, but it is read as integration. So integration. How do you understand by the term integration? When we talk about integration, we mean the summing up of numbers from a certain point to a certain point. So when we talk about integration, in brief, it is the reverse of differentiation. So you can just say maybe integration is the reverse of differentiation. Is the reverse of differentiation. So recall that d dx of x power n. So when you talk about d dx of x power n, we are meaning that when you differentiate x power n, what were you getting? We could raise the power, bring the power down n, then x power n minus 1, which was the process of differentiation. When we could say d dx of that was about differentiation. Now, from here, if we go ahead and look at the integration, and integration is denoted by elongated s, or written as which means integral. So from here, if we multiply out by dx from above, from d dx of x power n equals any x power n minus 1. If we multiply out by dx, we are going to remain with d x power n equals n x power n minus 1 dx. Now when we integrate, this is the symbol for integral. When you integrate, what happens? This d dies with the integral, we remain with x power n. We are drawing out that one, x power n. So when we are integrating, we add 1 to the power, then we divide by the new power. What happens? Add 1 becomes n plus 1, divided by the new power, which is n plus 1, plus c equals the same story. This becomes integral of n x power n minus 1. We said you add 1, divided by the new power. Negative 1 plus 1, you remain with only n dx. So what happens? Let's proceed. What happens with this? One look at that process, what comes out at the end? Because it's the reverse of differentiation. What comes in? So any process will remain with integral of x power n dx equals x power n plus 1 all over n plus 1 plus a constant. So from today, know that when you integrate any number with respect to what has been given, you add 1 to the power, then you divide by the new power which has come out. So dx means with respect to that function, variable which they have talked about. Now we are going to start with examples. Example 1. Integrate. When I say integrate, I'll be using that one. Integrate x power 2 dx. How do we get this one? We are looking at the solution. When they say integrate x squared dx is the same as, on this power, the power, we are integrating x squared with respect to x. There is a power of 2. What you do, you add 1. It is going to be x power 2 plus 1 divided by the new power. 2 plus 1, you get what? 3. Then plus a constant of what? Integration. What does it become? It becomes a third x power 3 plus a c, which is the integral of x squared dx. We have finished obtaining that one. So this is the first example. We are going to look at several examples as we are going to. We start from the lowest up to the maximum of it. So we need to be very careful and very attentive when we are dealing with these ones. So we are going to go to example 2. That was example 1. Then we are going to go to example 2. I want to look at how does example 2 look like. Example 2, it goes integrate 3x plus 5 dx. So how do we handle such a kind of numbers like this? We are going to look at the solution. We say integral of 3x plus 5 dx means every number, say as the integral, this becomes integral of 3x dx plus integral of 5 dx. What happens? 3 is a constant, you can bring it out. This is the same as 3 integral of x dx plus 5 integral. When there is a dx, you can see we cannot see x, just put x power 0 dx, because any number power 0 is the same as 1. So when here there is a power of 1, what do? Add 1 divided by the new power. This becomes 3 into x power 2 out of 2 plus 5. This becomes what? X power 1 out of 1, which is x plus a c. Now, when you integrate a constant, you get 5x. If you integrate x3, you get 3x. But if you differentiate a constant, you get 0. But when you integrate a constant, you get 5x, or if you have integrated 2, you get 2x. So what does it become? This is the same as 3 out of 2 x squared plus 5x plus a c. So you have already integrated what we call 3x plus 5 dx. That's how we integrate such kind of a number like that. So we are going to go on with another example. We're going to go to another example, which I want people to be very, very, very attentive and to be very, very serious with what I will be doing to you. So we're going to go to example 3. Example 3. They have said integrate 1 out of x power 4 dx. How do we handle this? When I say integrate 1 over x power 4 dx, what you do, take it up. Never integrate a number when it's down. Unless when the power is 1, we shall look at that. But if the power is more than 1 and is down, take it up. So this, we are looking at the solution. When they say integrate 1 over x power 4 dx is the same as integral x power negative 4 dx. What do we do with this? Add 1 divided by the new power. This becomes what? Tell me. X, we are adding 1, comes negative 3 out of negative 3 plus a constant of integration, which becomes a negative a third x power negative 3 plus a c. If you want to bring it down, we have no problem with that. If you leave it like that, still you have passed. Another one can say negative 1 out of 3x cubed plus a c, which is the integral of 1 over x power 4 dx. You are done with this. So we are going to go to another example. That is example 4. Because you come and say integrate 2x plus 3x squared plus a 4 dx. So how do we handle such a kind of a number like that? How do we handle such a kind of a number like that? When handling numbers of this nature, I say the integral goes on every stuff. So we're looking at our solution. It is saying the integral of 2x plus 3x squared plus 4 dx. What do? Every number say as the integral. Even if we don't guide that, we say this one with respect to everything. We are going to integrate 2x with respect to x, we're going to integrate 3x squared with respect to x, we're going to integrate 4 with respect to x. So we go ahead and integrate every number. So when you integrate this is by 1, you add a 1, this becomes 2x squared out of 2 plus, what about with 3x squared? We are only dealing with x. We say this becomes 3x power 3 out of 3 plus 4. When you integrate a constant, you get 4x plus a constant. Reduce, this becomes x squared plus x cubed plus 4x plus c. So we shall say therefore, when we integrate 2x plus 3x squared plus 4 dx, we are getting x squared plus x cubed plus 4x plus a constant of integration. That's how we can integrate these numbers. When we understand integrations, when it comes to math paper 2, it will be a walkover on what we shall be doing. So we are going to proceed to another example. Another example. We're going to go to example 5. We're going to go to example 5. We're going to go to example 5. So we want to go to example 5. Example 5. Example 5. It goes integrate x plus 3 power 4 dx. So can we integrate that? Now, here there are two ways. The first step is you can first open the brackets. You can expand it, but it may take you time. What we normally do here when that you consider the number is having a greater power, always let that function which is appearing several times to be a u, to be a t. You can use like the idea of changing what you did in differentiation. So for this case, since this one is taking a bigger power, we are saying integral of x plus 3 power 4 dx. We are going to say let u equals x plus 3. So go ahead and differentiate. We are going to go ahead and differentiate that function being given to you with respect to x. So can we proceed? When you differentiate this u, you get du equals dx. So this implies that integral of x plus 3 power 4 dx is the same as integral of u power 4 times. Where there is a dx, our dx has now changed in terms of du. What do you do? Add 1 to the power divided by the new power. What does it become? 1 out of 5 u power 5 plus a constant of what? Integration. Constant integration means the recurring, it goes on. Of course, you don't know where you have started from. So do we know our u? Go back. What is our u? Our u is already x plus 3. So we say 1 over 5 into x plus 3 power 5 plus the constant of integration. That's how we normally deal with numbers which have got a greater power. Don't always go ahead and simply say you're going to first open the brackets. It may take you time. Always use that idea of relating. So we are going to go to another example. That is example 6. They are saying integrate 2x plus 5 power 3 dx. So how do we handle such a kind of a number like that? The same story, with this. You let a u to be the number which is inside, which is taking the bigger power. We are going to say let u equals 2x plus 5. So can we differentiate? When we differentiate a u, we get a du. Du equals, here we're getting 1. When we differentiate 2x, you're getting 2. When we differentiate 5, you're getting this, so it remains dx. Or you can say du dx equals what you have got, then you cross multiply. Then make dx the subject. What is dx? Dx is the same as du out of 2. This implies that integral of 2x plus 5 power 3 dx is the same as integral. Where there is 2x plus 5, just put a u. It's the same as integral of u power 3 times. Where there is a dx, we are going to put du out of 2. Now, we are integrating u cubed with respect to u. A half is a constant. You can eliminate it, you can bring it out. So this becomes a half integral of u cubed du. Do we know our u? Well, when we integrate u, what do we get? We get a half. Add 1 u power 4 out of 4 plus c. What does it become? 1 over 8 u power 4 plus c. But do we know u? Our u is already 2x plus 5. So this becomes 1 over 8 into 2x plus 5 power 4 plus the constant of integration. That one becomes our clear answer for that. So when the number comes in that kind of expansion, always the number which let the number which is being expanded several times to be another variable. So we can proceed to another example. In this case, we are going to do several examples until when we come out with a clear answer for that, until when we understand most of these concepts. So we need to be understanding all these concepts such that at the end we can easily do the best. So we are going to go to example 6. Is saying integrate 1 out of 3x minus 2 power 4 dx. Now, same story here. Look at this number. They are saying integrate 1 all over 3x minus 2 power 4 with respect to x. What do we do when a number comes in this format? Here what we do is very simple. You take the power up. The same story. You take it up, then the power becomes what? Negative. So we are looking at the solution. We are saying integral of 1 all over 3x minus 2 power 4 dx is the same as integral, take it up, 3x minus 2 power negative 4 dx. Go ahead. The number which is being expanded up to the power of negative 4, call it to be a u. We say let u equals 3x minus 2. Can we differentiate? We get the u equals 3 dx. Make dx the subject. What is dx alone? It's going to be du out of 3. This implies that integral of 1 out of 3x minus 2 power 4 dx is the same as integral of u power negative 4 times. Where there is this dx, you are going to bring this stuff of du out of 3. You factor out 1 out of 3. Integral of u power negative 4 du. What do we do? Add 1 divided by the new power. This becomes 1 out of 3 into u power. Add 1 becomes negative 3 out of negative 3 plus c. What does it become? Becomes negative 1 over 9 u power negative 3 plus c. But do we know our u? Do we know our u? Our u is already 3x minus 2. So this becomes negative 1 out of 9 into 3x minus 2 power negative 3 plus c. So if you want to take it down, you can still take it down. No problem with it. So we said therefore integral of 1 out of 3x minus 2 power 4 dx is the same as negative 1 out of 9 into 3x minus 2 power 3 plus a constant of integration. So that's how we do such a kind of the numbers. So somebody there was asking if the power is beyond 7. The same story. You can even do that related to that, such that at the end there is no any core of an alarm that why you used to do these numbers of a smaller power. Never. No. So we are going to doing more and more which are related to that, so that at the end everybody can easily understand the best in it. So we are going to look at example 7 for saying integrate integral of 5x plus 3 power 8 dx. So it's going to be the same theory. The same story is going to come out with this. What do you do first? When a number is set in that manner, the first step, which I emphasize to all of you, the first step, you cannot expand that thing to a point. You can expand the whole of this whiteboard can come to an end when you have not seen, you have not even come to the conclusive to it. Even if you use Pascal's triangle, it will take you time. So the best thing you do is that number which is in the question, let it to be a u, such that you can easily move on. So we are saying integral of 5x plus 3 power 8 dx. We are going to say that u equals 5x plus 3. Can we differentiate? This is du equals 5 dx. Can we make dx the subject? What is dx? Dx is the same as du out of 5. This implies that integral of 5x plus 3 power 8 dx is the same as integral of u power 8 times, where there is a dx, we put du out of 5 because we have already changed everything from x in terms of u. So we factor out the constant, which is 1 over 5 integral of u power 8 du. What do? We say 1 over 5, add 1 becomes u power 9 out of 9, then plus a c. So guys, this becomes 1 over 45 u power 9 plus a c. So do you remember our u? Check our u from up. We said therefore when you integrate 5x plus 3 power 8 dx, we are getting 1 out of 45 into 5x plus 3, 5x plus 3 power 9 plus a constant of integration. That's how